Hello and thanks for watching Best Maths Tutor's first live stream, and we're going to do quadratic equations today. So the order that we're going to do them in is we're going to start off doing the factorisation of simple quadratics, that one, and then we're going to move on to factorising more difficult quadratic equations, and then finally using the quadratic formula. There are other methods you can use for this, so you can also do completing the square and solving graphically, but just because of time constraints I think we might cover those on another video. So and also just to give you an idea of the level of these ones, factorisation of simple quadratic equations is probably around level 5. Okay, so that's or grade 5 I should say. Oops. Grade 5, and the more difficult quadratic equations and the quadratic formula, they're about grade 7. So, so moving on, then I'm going to look at the simple quadratic equations. So I've got two examples here, and hopefully what I'm going to do is increase in terms of difficulty as I go through as well. So this is the most basic one, and when it says solving a quadratic, the first thing that we actually need to do is factorise it, which means put it into two brackets. So we're going to factorise. My writing's gone a bit funny here. I think the scale on my graphics pad's gone a bit strange. So if we're going to factorise, that means put it into two brackets like this. Okay, multiplied together. And when that bracket if these two brackets were multiplied out, what they'd have to give us is this quadratic expression that we've got at the top. So the first term in each bracket, when we've got a simple one, and that means there's no number here in front of the x squared, then we'd actually just have an x and an x at the beginning of each bracket. And what we've got to do is we've got to decide or try and work out what number is going to go here and here. And it's with the simple ones, it's relatively easy to find these two numbers, because if we have a quadratic equation in the form ax squared plus bx plus c equals 0, well, for the simple quadratic, a is actually equal to 1, so we don't see a number. And we've got a number, in this case, b is equal to 6, and we've got c is equal to 8. And the two numbers that we need to put here and here must multiply to make c. To make c. So multiply to make c. So they've got, in this case, got to multiply to make 8, and they've got to add to make b, so the number that's multiplying the x there. So in this case, b is equal to 6. So we're looking for a number which is going to multiply to make 8, or two numbers which are going to multiply to make 8 and add to make 6. So we just got to do a bit of just messing around with numbers until we can find that. But we can see that 4 and 2 would actually multiply times to equal 8, and we can see that they would add to equal 6. So these are the two numbers we're actually interested in. So we could put those into our bracket. So we could have 4 there, and then we could write the 2 there. So we've got x plus 4 and x plus 2 is the correct factorisation of this. I'm just going to make a little bit of space. So I can just select this and move it down. Yeah, there we go. That's better. So we've factorised it in the form x plus 4 times x plus 2 equals 0, and because it's equal 0, there's only one way that could be the case. So either the x plus 4 would have to equal 0, or the x plus 2 would have to equal 0. So because we've got these two equations, there's only one way that that first one could equal 0, and that would be if x was equal to minus 4. So we can see that if x was equal to minus 4 plus 4 would actually equal 0. So that's one solution. And the other solution is if x plus 2 is equal to 0, then we could say that x would have to equal minus 2 for that to be the case. So there are solutions for that first one. We've actually got x equals minus 4 or x equals minus 2. So that's our solutions there for the first example. So I'm just going to create a bit more space here. So just move all this down a little. Right, so this one is a bit more difficult because we've got negative signs involved. So we've got a minus 7x. So when we're trying to get a bracket to factorise it, so two brackets, we know that the first terms in each bracket are going to have to equal x. So that's going to have to be an x there, and that's going to have to be an x there. But the two numbers that we're looking for, the one that goes there and the one that go there, have to multiply to equal the last number. So we've got times to equal 12, and they've got to add to equal minus 7. So we've got to have a little think about that. And the only way, if we multiply two numbers together, there's two ways we could actually get that. We could have two positive numbers multiplied together would give us a positive answer, but we also need to know that two negative numbers multiplied together will give us a positive outcome. So if we think about the factors of 12, we could see that 3 times 4 would give us 12, so that could possibly be the right answer. But 3 plus 4 gives us 7, so that it can't be a positive 3 and a positive 4. But if we look at negative 3 and negative 4, well, if we times them together, they would still give us positive 12, because a negative times a negative is a positive. However, also, if we take negative 3 and we add it to negative 4, we'd actually get negative 7. So that's correct. So the two numbers we're interested in is minus 3 and minus 4. So we can actually write them in here. Minus 3 and minus 4. And because that's still equal to 0, then we end up with two mini equations from each bracket. So we end up with either x minus 3 is equal to 0, or from the second bracket we end up with x minus 4 equals 0. So the only way that could be true would be if x was equal to, this time, positive 3, or the other solution is that x is equal to positive 4. So that's our first one, our second one solved there. Moving on to these getting progressively more difficult. So I'm just going to make a bit more space again. So I didn't actually realise how much space these were going to take up when I set it out originally. So I'll just move that right down. See if I can move that. So this one now, number 3, has got a negative for the what I call the coefficient, which is the number multiplying the x there. So we've got b is equal to -1, and we can see that c is equal to -56. So we're actually, when we put this into our brackets again, so there's our brackets. The first term in each bracket is going to be an x, and that's because x times x, if we was to multiply these brackets out, x times x would actually give us the x squared there. And the final term then has got to multiply, so it's got times to make -56, and it's got to add to make -1. So if we're thinking about that, if we think about the factors of 56, well, for example, 7 and 8 would multiply to make 56. However, they wouldn't multiply to make -56. What we need is one of them to be positive and one of them to be negative, and that's because positive times a negative will actually give us a negative. Okay, and so we could have some alternatives. We could have -7 and +8, for example, would multiply to give us -56. However, if we added them together, -7 plus 8, that would give us +1. So that's not quite right. It's close. So I'm going to try making the signs the other way around. I'm going to go +7 and -8. Now they do multiply to make -56. So there would be possibilities for the right answer for this. And actually, if we add them together, +7 take away 8 is actually -1. So those are the solutions we're looking for. So we can put them into the brackets, +7 and -8. So if we consider that those are now, that's equal to 0, then what we're going to get is x +7 is one way that we could have a solution to this, because either the first bracket is 0 or the second bracket is 0. So if x +7 equals 0, then that gives us a solution which is that x is equal to -7. And from the other bracket, x -8 is another alternative, and that's equal 0. And the value of x which would make that true would be that x is equal to 8. So there are solutions for that one. So I'm going to move on there. So this is an exam style question. So I thought I'd put one of these in at the end for this section. And we can see it's sort of broken down a little bit. So first of all, we're asked to factorise it, which is what we've been doing anyway. And then we're going to use the result for part A to try and solve part B. So we're going to try and put this into two brackets. So again, just writing out the two brackets, we've got this. So we can say we've got an x and an x. And okay, so that's we're looking for two numbers which are going to multiply to give us the -48, and are actually going to add to give us -2. So we've got a times to equal -48, and they've got to add to give -2. So if we ever think about that, so we're looking for the factors of 48 is probably a good place to start. We can see that 48 could be given by 6 times 8. However, that would give us a positive result. So, because a positive 6 times a positive 8 would only give us +48. So we need one of these numbers to be negative. So I'm going to choose the 8 as the negative one, because we can see that 6 plus -8 will give us -2. There we go. So our two numbers that we're going to put in the brackets then are 6 and minus 8. So I'm going to put them in there. Plus 6 and minus 8. And so that's now factorised. I've not really spoken about this yet, but if we, just to show why that is the same thing, if I just write this here, x plus 6 times by x minus 8, if we were to multiply them out, what that means is, so multiplying double brackets, we'd be taking the first terms, multiplying them together, and that would give us x squared. Then we could multiply the first, or the outside terms, as I would call it. There's a system actually called FOIL. So that stands for first, which I've just done, the first terms. Then the outside, so that's the x times the negative 8, so that gives me minus 8x. Then we've got the inside, and that would be the inside terms is the 6 times the x, so that's plus 6x. And then the last terms, if we take the last terms in each one, we've got 6 times negative 8. So that's equal to, 6 times negative 8 is equal to minus 48. And if we tidy that up, we end up with x squared minus 8x plus 6x is actually minus 2x, and that's minus 48. So that gave us what we had originally there. So we can see why these are equivalent. And now it's asking us to solve this. So what we can do, we can take the factorisation of it, x plus 6, x minus 8, and that's equal to 0. And we can say that from that, we've got two little mini equations. We've got either x plus 6 equals 0, so x is equal to minus 6, and from the second one, x minus 8 equals 0, so that gives us that x equals 8. And so there are two solutions, so we would just write those in here, minus 6 and 8. So knowing that is enough to give you a grade 5 if you can do the simple quadratics. So if we move on to the harder quadratic equations, I'll give myself a little bit more space here. No doubt I'm going to have to rearrange the board again. So we can see this is harder because we can see we've got a number in front of the x squared. So that makes it much more difficult. And there is a few ways of doing this. So I'm going to give you one of the methods. And we can see that if we write a quadratic in its general form, we can say it's ax squared plus 17x plus 10 is equal to 0. So that, sorry, I've just made a little mistake there. That was not what I meant to say. I'm actually meaning to say ax squared plus bx plus c is equal to 0. So if we want to solve an equation like this, we need to put it into two brackets. And what we need to do is we need to look for a product. So that means times, actually. I could have said times, but a product which is a times by c. And a sum, and a sum is addition, which is equal to b. So we're looking for two numbers again. It's a bit similar to the simple quadratics, but the product's got to be a times c, and the sum's got to be equal to b. So in our case, I'm just going to list what a, b, and c is, and we've got a is equal to 3, b is equal to 17, and c is equal to 10. So we're looking for, if we try and apply that thing I've just done above, the product then is a times c, so it's 3 times 10. So we're looking for two numbers which have a product of 30 and which have a sum of whatever b is, and b is 17. So sum's got to be equal to 17. So think about that. Two numbers which multiply to make 30 but add to make 17 are actually 15 and 2, because we can see 15 plus 2 will give us 17, and 15 times 2 will give us 30. So what I'm going to do is we then take this middle number and we split it up. So we rewrite this quadratic that we've got. So we take it as 3x squared, and then we write the 17x as 15x from that 15 plus 2x plus 10 equals 0. So that's really the same as the one we were given in the question. We'll just split up the middle number there. So we split the equation into two halves. And often people will draw a wiggly line like that in order to do it. So I'm going to now try and factorise the first bit. So factorise the first half. I'll just write down the step there. So factorise the first half. So if we do that, then what we end up with is we can take a 3x outside to the front, and that would mean that we'd end up with an x plus 5 in the bracket. Because we can see 3x times x would give us 3x squared, and 3x times 5 would give us 15x. We also now do the second half. So factorise a the first half, b second half. So if we do that, what we end up with is common factor in there is just 2, so we can take out a 2, and then in a bracket I'm going to get x plus 5. That's all equal to 0. And now we can see if we've done this correctly, that should be a positive 2 by the way, if we've done this correctly, then the x plus 5 and the x plus 5 have got a repeated bracket. So if we bring the first part of the brackets, what's multiplying each one of the brackets, there and there, we can actually put them into another bracket. So we get 3x plus 2 and x plus 5. And now that's the full factorisation of the quadratic we had originally there. So that's still equal to 0. And we end up with two equations now. So we end up with 3x plus 2 is equal to 0. So I'm just going to solve this a little bit more slowly than the ones I've done before. So I'm going to take away 2 from both sides, which will give me 3x equals minus 2. And then I'm going to divide by 3. So divide both sides by 3. 3's will cancel. And I'll end up with x equals minus 2/3. So that's my first solution there. And my second solution is from the second bracket, which is x plus 5 equals 0. So we can say that x equals minus 5. So there are two solutions. So now I'm going to move on to a slightly harder one. So we can see the reason I'm saying it's harder is because we've got negative signs, and that's always going to make it a bit more tricky. So that's supposed to be an arrow there. There we go. So we're going to do the same thing. We're going to consider it in the form ax squared plus bx plus c equals 0. And I'm going to write down what a, b and c are. So I'm going to say, well, a is equal to 4, b is equal to minus 19, and c is equal to minus 5. So, as before, we're looking for a product, which is the a times the c. So, if I multiply the a and the c together, what I end up with is minus 20. And the sum is actually the b. So the sum is minus 19. So we're looking for two numbers which multiply to make minus 20 and add to make minus 19. So these two numbers. So it can take a little bit of thinking to try and find these numbers. We might want to start by looking at the factors of 20 and starting there. But I can see that minus 20 times by 1, positive 1, would give me minus 20. And in fact, if I added minus 20 and 1 together, then I would get minus 19. So those are the two numbers that we're interested in, minus 20 and 1. So I'm going to split this middle number into those, split the 19, or minus 19x, into these two numbers. So I'll rewrite it again, and I'll get 4x squared minus 20x, and then plus 1x. So we can see that minus 20x and plus the 1x will in fact give us minus 19x. Then we can take away 5, and that's still equal to 0. So we're going to draw the wiggly line, split it into 2, and so we can see that we've got 4x is the common factor of this first half. So we can take 4x out, open up a bracket, and we're going to get x in that bracket, and then minus 5. Okay, because we can see that 4x times minus 5 will give us minus 20x. And then if we do the same thing to the second bracket, now it might not look obvious that there's a common factor in those, but we can actually just say, we can't spot anything, we can just take 1. So I'm going to take a 1 there, and then open up a bracket. And in the bracket, I'm going to just get x minus 5. Because 1 times x minus 5 is x minus 5. And then we're going to bring these two bits together. Oh, hi, we've got, hi Balian. Thanks for communicating with us. Any questions you've got, please let me know. So we're going to bring the 4x and the 1 together. So if we do that, 4x plus the 1 forms one bracket. Thanks very much. X minus 5 is the other bracket. So and if we so that second bracket comes from the x minus 5 and the x minus 5 there. So that's the second bracket. And from that we can then get two little mini equations. So we can say 4x plus 1 equals 0. And from the other bracket, we've got x minus 5 equals 0. So if we try and solve this one, we get 4x equals minus 1. Just taking away the 1 from both sides. And then from that, I'll just do an arrow here. So the next step from that would be just to divide both sides by 4. And then we end up with x equals minus a quarter. That's the first solution. And the second solution is a little bit easier because just if x minus 5 equals 0, then x must equal 5. So there we go. That's that one. So I'm just going to move on there. So I realise this might be overkill, but I'm just going to do another example on this. So again, we've got a more difficult one because we've got negative signs here. Okay, and what we can do is we can take the ax squared plus the bx minus plus the a, Sorry, I'm just getting a couple of mistakes there. Let me just rewrite. So plus the C, and we're looking for a product, which is the A times the C, and a sum, which is just the B. So in our case, the product is the first number there times the negative 24. In fact, I'll just write these below. So A is equal to 5, B is equal to minus 37, and C is equal to minus 24. So what we can do is we can say, right, well, the product's going to be 5 times minus 24, so that's going to be 120, minus 120. And the other one is, we've got a sum, which is the minus 37 there. So what we're going to do then is we're going to try and find two numbers which multiply to give us the minus 120 and add to give us minus 37. So that's fairly tricky to do that, but so it's just a case of playing with numbers. We can see that minus 40 times by 3 would give us minus 120. So, and if we do the sum of those, minus 40 plus 3, then that's minus 37. So those are our two numbers then, so minus 40 and 3. So I'm going to rewrite it by changing the minus 37 into minus 40 and 3. So if I do that, I've got 5x squared minus 40x and plus 3x. And then we've got minus 24. So there we go. We're going to split it there. And what we're going to do is we're going to try and factorise this first half. So we can see we've got a 5x as a common factor there. And so we can see that we get an x there, because 5x times x will give us a 5x squared. And then we've got just a minus 8. 5x times minus 8 will give us minus 40. And if we look at the second half, you can see that we've just got a 3 is the common factor there. 3 means we need an x there to give us a 3x. And then that's going to be minus 8 is equal to 0. And that's good news because we've got x minus 8 and x minus 8. So if we get a repeater bracket, we know we're doing it okay. So then what we do, we just take the first part in front of each bracket there, form a new bracket with them. So I've got 5x plus 3, and then we just use our x minus 8, which is the repeater bracket. So that's now fully factorised, and I'm just going to create two equations from that. 5x plus 3 equals 0. So if I solve that, I can just take away 3 from both sides. 5x is minus 3, and x is minus 3 over 5. And the other bracket is x minus 8. That's equal to 0. And so if that's the case, then x must equal 8. So those are our two solutions for that one. So now what I'm going to do is move on to using the quadratic formula. So obviously quadratic formula, you would get that on a calculator paper. So here's an example. So up at the top, what I'm going to do is I'm just going to write down the formula. So again, what it is, it's if we've got standard form for a quadratic, so i.e. if we have this, if we have ax squared plus bx plus c equals 0, and it's always important to make it equal 0 as well. So you might have to rearrange the equation so that it does equal 0. And if that's the case, then you can say that x is equal to minus b plus or minus, I'll explain what that means, the plus or minus, in a minute, the square root of b squared minus 4ac all over 2a. So that looks incredibly complicated at the moment, but it'll all make more sense when we actually put real numbers into it and look at this example. So whenever I was, and a good tip is, if you're doing these and you're wondering, should I use the formula or should I use factorisation, a good tip is, if it says use decimal places, then that is going to tell me that I'm going to use the formula. And the reason for that is because the answer will be something with a decimal, which we could never think of two brackets where it might be x plus 6.2 or something like that. We could only really think of whole numbers. So if the answer is not going to be whole numbers, then it's got to be the formula. So the first step that I would always do is write down what a, b and c are. So in this example, a is equal to 1, b is equal to 5, and c is equal to 3. So what I'm going to do is, it's just a case of substituting them into this equation. So that means that x is going to be equal to minus whatever b is, so that's 5, plus or minus the square root of, and then it's b squared, so that's 5 squared, minus 4 times a is 1, so that's what I'm putting in the formula there, the a, times 1, and c is 3, and then it's all over the 2a there, so it's 2 times whatever a is, and a is equal to 1. Now, that looks a bit complicated, and we might want to simplify bits of it before we put it into the calculator. But with modern calculators, like this one that I use, this is a ClassWiz calculator. I'm just using the emulator for it. We can actually enter all this in one go. So I'm going to press the fraction button there. So that's our fraction button. And I'm just going to enter everything in. So I've got minus 5. And then now, because this plus or minus bit here is actually there because it splits into two answers. So we look at it first of all when it's plus, and then we look at it when it's minus. So I'm going to put the plus version in first of all. So plus, and then the square root, so there's a square root button, of 5 squared, there's squared, minus, and just putting this straight in, 4 times 1 times 3. And then I'm just going to use the navigation keys. So these are these ones in the sort of donut shape. I'm going to go down to the bottom. I'm just going to put in 2 times 1. And so it's all there. I'm just going to press the equals button. And we can see we get this, it doesn't look right yet, does it? But what we can then do, because this is what's called surd form, which is the exact form. So what we can do is, if we press this button, which is SD, it'll toggle between it looking like this to it looking like a decimal. As we can see there, it's negative 0.69722. So negative 0.69722 with a few more decimal places after that. And we can, because we're asked to do it to 2 decimal places, so to 2 decimal places, we're going to cut it off there. So we're going to add 1 onto the 9, so it's going to go to a 10, which means it's going to carry on into the 6. So we're going to get negative 0.70. And it is important to write the 0 there, because if we didn't, we'd have actually done it to 1 decimal place. And then what I'm going to do is just get the calculator up again. I just realised I think you might not be able to see how I've rounded that up because of the calculator showing. So just doing this here again, minus 0.6, that will go to minus 0.70. Okay, when I round it up to 2 decimal places. So the easy way, when you've got it all entered in the calculator, we want the positive version now. So the negative version is, I'm just going to go use my navigation buttons, and this is take myself back to where the plus is, and then just press delete, and then press negative, minus. I've just got all the same numbers in, but just swapped it over to the negative one there. And if I press equals, there we go. I've got a slightly different answer now. I just press the SD button, and we can see we've got minus 4.3027. So the other answer, and I might want to say all, equals minus 4.3027. And to 2 decimal places, supposed to be an arrow there. That's equal to minus 4.30. So that's that. We've done that one. So I'm going to move on to a slightly more difficult one. I think we'll bypass this one and we'll move on to ones with negative values, because they're the most difficult ones actually. So the only difference on the previous one is that it's a 2. So it would be a case of substituting a equals 2 rather than 1. So going on to this one, it's got negative values. So we're going to just write down what A, B and C are again. So A is equal to 3. And now what's very important is to use the negative there. So B is equal to negative 11 and C is equal to negative 13. And if you remember our formula, so x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're just going to substitute these values into it. And so we're going to get that x is equal to, now we've got to be very careful with negative signs, and so I'm going to put brackets in around the things I'm substituting in. So minus 11, although we might know that that's going to just give me positive 11 there. And then we've got square root of, and I'm going to put that in a bracket. So minus 11 squared. The reason for that is we have to worry a little bit about BIDMAS, which is the order of operations. So if we don't put that in a bracket, we're actually going to square 11 first, get 121, and then think that it's minus. Whereas if we put it in a bracket, we're going to square, so we're going to square 11, negative 11 squared, that's 121. But minus 11 squared is actually minus 121, according to the rules of BIDMAS. So it's very important to do that in the right order. So now we've got to go over minus 4 times the a, which is 3, times by the c, which is minus 13, and then that is all over 2 times by the 3. So what I'm going to do is just get that onto the calculator again. So again, this is just a case of substituting into my calculator. So I'm going to use the fraction button. Minus 11, I'm just going to enter that as 11 because negative times negative is a positive. So I'm just going to put that straight in as 11 just to save typing too much. I'm going to take the positive answer there. So we're going to look at the positive one first. Square root, and now I'm going to put this in a bracket. So I'm going to just open up a little bracket there. Minus 11 and then I'm going to square that result, minus 4 times 3 times, and then open up a bracket again. And if you use brackets, it just saves you making lots of mistakes with negative signs, which is where most of the mistakes, as people move on in maths, most of the mistakes actually do come from negative signs. So if you do A-level maths, it's the negative signs that's going to get you. So looking at the bottom of this, we've got 2 times A, 2 times 3, and so let's have a look what we get for that. Press the equals. So we've got, again, this is called surd form, and this is in exact form. And if I just press the SD button, it's going to toggle into the form that I'm requiring. So we can see, there it is, 4.6072. So let me just do that. So that's 4.6072. And what I'm going to do is just try and round that up to 3 significant figures. So 3 significant figures actually means start counting not from the decimal point, but from the first figure that's not 0 in the number. So there we go. This is our first significant figure, second, third. So that's where we're going to cut it off. So actually that's equal to, because the 7 is 5 or more, I'm going to add 1 onto the third place. I'm going to get 4.61. And there we go, 4.61. And we're now going to look at the other answer. So if we go back through this button again, look at the negative one. So where are we? I'm going to just change that now, get rid of the positive. So delete that, make that a negative, and then just press equals. So that's the other solution. Again, insert form, so press the SD button, and that's our other answer. So minus 0.94055. So, or minus 0. I just need to get my calculator up again. 94055. And if we write that to 3 significant figures, now the first significant figure is not the 0, it's the 9. So that's first, second, third. So I think this question is trying to probably catch us out a little bit in case we thought it was from the 0, but it's actually the first number that's not 0. And so we're going to cut it off here. And because it's a 5, that means we're going to add 1 to the 0 just there. And so that's going to give us minus 0.941. So I hope that's been helpful actually. And if there's any more topics you'd like us to cover, then please give us some comments and let me know what you think. And like our video and subscribe to our channel, of course.